Welcome back to the Math Professors. If you're looking for content that can be found in any college math class, please consider liking, subscribing, and sharing. Today, we're going to do a hypothesis test, and specifically on Mendel's study of genetics. So, when Mendel did his work with pea pods, he found when crossing the pea pods that 152 of the 580 were yellow, and then 428 of those 580 were green. So what I want to do is I want to use the significance level of alpha is equal to 0.01 to test the claim that 25% of the pea pods will be yellow. And it really comes down to this Punnett square that you might do in a biology class that when we're trying to do genetics, we know that the greens were dominant and the yellows were recessive. So when you set up this Punnett square, if I have pea pod, the GG is going to give us a green pea pod. Now the G and the little Y is going to give us still a green because G is dominant. Over here we're still going to get a green, but over here we're going to get a yellow. So what we can see with this is there's a 25% chance of you getting a yellow pea pod if you cross these things. So let's do a hypothesis test. So the first thing we want to do is really want to kind of talk about the claim. So step one is just figure out what the claim is. So the claim is that the proportion of yellow will be 25%. Now, step two, what we'd like to do is we'd like to set up the claim, and what we're going to do is we're going to put this in symbolic form. So proportion being P is going to be equal to 0.25, and then next we want to do the opposite of that. So either you are equal to 25% or the opposite is going to be not equal to 25%. Now step three, we're going to write this now in terms of your hypothesis. You're going to have the null hypothesis, and then you're going to have the alternative hypothesis. Now the null being, when the things are equal, and the alternative is when it's not. So when I ask the students, one of these is going to be the null, the other is going to be the alternative. It's not always the claim. The reason why the claim is the null hypothesis is because the claim has equality in it. So this is going to be equal to 25%, and the alternative is going to be when it's not equal to 25%. Now at 4, we want to identify our significance level, and they say use a 0.01. Now over here, when we look at the alternative, because 5, what we're going to do is we're going to have our test statistic. And 6, what we're going to do is we're going to write this in terms of our bell-shaped curve, and we need to figure out, on this bell, how many tails does it have? Now, since our alternative has a not equals, we know that this is going to be two-tailed, which means we're going to use alpha over 2 for each one of these tails. So 0.01 divided by 2 is going to be 0.005. Say 0.01 divided by 2. Let's do the math. 0.01 divided by 2 is going to be equal to 0.005. So that's what area I have here. Each one of these is going to be 0.005. This is also 0.005. So what we're going to have to do is we're going to have to eventually find these critical values, which are going to be z-scores. So we'll call this z alpha over 2. Now, test statistic. Well, the test statistic is the z-score that comes from your particular sample. And this is set up by finding, this is p hat minus p all over the square root of pq divided by n. Now, what we know is p hat is going to be, the proportion of yellows. So what I know is I have 152 yellows over the total. So 152 plus 428. So I have 152 all over 580, which gives us 0.262 rounded to 3 decimals. So when I set this up, this is going to be 0.262 minus 0.25, all divided by the square root of 0.25 times 0.75, and this is going to be divided by the total, which n is going to be equal to 580. Now, be careful when you're plugging this into your calculator. Like, doesn't know order of operations, you have to tell it the correct thing. So make sure to put that numerator in parentheses. The denominator is already grouped. So when we plug this in, we get 0.67. Now I need to know how that sample z-score relates to our z alpha over 2's. And really all we have to do is just go to your z-score table and remember that I'm trying to find an area of 0.005. So what I'm looking for is 995. So what I mean by that is your z-score table tells you area to the left. So if this is 0.005, the area to the left, including even that tail, is going to be 0.995. So that's going to give us a z-score of 2.575. That means this side is going to be negative 2.575. Now this z-score, this 0.67, actually lives, remember the center area is going to be our null and the tails are going to be our alternative, so that 0.67 lives right there. There's another way to do this as well. I just did it using critical values. Now if I want to do this using a p-value, what I have to do is I have to determine, the area that this 0.67 gives. Now I have to be a little bit careful. I don't really want the area, but I actually need twice the area because it's two-tailed. So what I'm going to do is I'm going to find the area of that green for that 0.67. So when you look up 0.67, (7.486), this is going to be equal to 0.7486. My bad. That's actually this white area. This is going to be 1 minus that. So this is going to be equal to 0.2514. Now that would be actually comparing, this area to this area. So what we can see is that 0.67 lived in the null because it's beyond our critical region. Now you can either compare this with the alpha over 2, but what the p-value does is it goes back and it compares it with this instead. So the way I got this was divided by 2, so the way I undo it is I'm going to have to multiply it by 2, which means I'm also going to have to multiply this by 2 as well. So if I want a p-value for a two-tailed test, is going to be 2 times, whatever area that gives. Now, I had to do area to the right because this 0.67 was right of center, so that's why this was 0.2514, that area. So this is going to be equal to 0.5028. So there's 2 ways we can talk about this. So 7, what I'm going to do is I'm going to fail to reject the null. I'm going to fail to reject the null because what we can see is that this 0.67 lived in that null. Also, another reason why we can say we fail to reject the null is because your p-value is greater than your alpha. Much, much greater than your alpha. So that's why we failed to reject that null. Now, number 8, failing to reject the null means that the null is where we are. So, this is where we are. And that means that this matches the claim, which means we're going to support that claim. Now the way we if you like the videos, please subscribe.